Okay, so we're going to be working with square roots that have fractions in them. And what most of us would do here is we would say, well, I've got this fraction, 36 divided by 4. I can simplify this. So that would become the square root of, and 36 divided by 4 is 9. So now we just have the square root of 9, so that would just be 3. And we'd be done. And that works just fine. Maybe a few of us might have looked at this and said, hey, what if I change this? So we have the square root of 36 over 4. And what if I wrote it like this? And I said, can I take the square root of 36 and divide that by the square root of 4? Does that work? The square root of 36 is 6, and the square root of 4 is 2, and 6 divided by 2 is 3. And so it does work, and it actually leads us to the quotient property of square roots. So this quotient property of square roots is great. It allows us to simplify expressions with square roots in a different way. So let's look at this property. So if I have the square root of a over b, that equals the square root of a over the square root of b. And I can then move from there and simplify the expression in a different way than if we couldn't do, if we couldn't simplify a divided by b. So we do have to note that a has to be greater than or equal to 0, and b is greater than 0. Because if a is less than 0, then we're taking the square root of a negative, and b cannot be 0 because then you're dividing by 0. So let's look at some examples with this. Here's two examples. We got the square root of 100 over 36 and the square root of 75 over 12. Now in this one, you'll probably notice really quickly that these are both perfect squares, 136. So this one will be pretty simple and straightforward. This one we're going to have to do a little bit of work over here because we've got 75 and 12. Neither of those are perfect squares. So we'll spend some time on that one. So I'm going to start with the square root of 100 over 36. And I'm going to change this to the square root of 100 divided by the square root of 36. So the square root of 100 we know is 10, and the square root of 36 is 6. Now we just have to simplify 10 over 6. These are both divisible by 2. So if I divide the top by 2 and the bottom by 2, I would get 5 over 3, and that is our simplified version. Another way of simplifying that fraction, we could rewrite that as 2 times 5 over 2 times 3. The 2's will cancel, and I'm left with 5/3. So another way to do that, which is how we've shown in class. The square root of 75 over 12. So we could simplify 75 12ths, just like we could have simplified these both of these here by dividing them by 4. We could have done that. Both of these have a common factor as well, and we could simplify the fraction before we start to take the square root. So that's an option. And if we do that, it'll make it a little bit easier. But if we didn't notice that and we just started working by rewriting this as the square root of 75 over 12, I'll show you how to simplify in that case. But you could simplify the fraction first and then work through it. So let's just simplify this. 75, the square root of that, if we write the prime factorization for 75, that would be 5 squared times 3 over, and then 12 is 2 squared times 3. And so we've got two perfect squares. We've got this one, a perfect square, and we got this one. So that we can take the square root of both of these. This one is not a perfect square, and neither is this. So these are both going to stay inside the radical. So what we end up with is the square root of 5 squared is 5. And then we have that 3 left over on the inside. Okay, so that's the numerator. In the denominator, we've got the square root of 2 squared, which is 2. So that comes out of the radical. And then we have that square root of 3 left inside. Now, because we didn't simplify this from the beginning, we have this square root of 3 divided by square root of 3 here, which we can actually simplify. We can cancel that out, because really what's going on in the numerator is we have 5 times the square root of 3 over, and then in the denominator, 2 times the square root of 3. So just like if this was 3 over 3 or 10 over 10, you can cancel this with this, and you're left with 5 over 2. Okay, again, this time we're going to have some variables in here, and again, we could simplify first if we notice that we could do that, and it will make it easier if you do. If you don't, that's totally fine. So maybe we'll do it both ways. We'll simplify first. So 108 and 3, they have a common factor of 3. So 3 goes into 108. That would go in there 36 times. So you've got the square root, the square root of 36. And then p to the 10th divided by p to the 2nd is just p to the 8th. And so now we just have the square root of 36p to the 8th, which would be the square root of 6 squared times p to the 8th. So that's just 6p to the 4th. Okay, so let's check. Let's do the same thing here, but we'll do it without simplifying first and see if we can come up with the same value or same expression. So I'll rewrite that. We've got the square root of 108 p to the 10th over the square root of 3p squared. So 108, let's find the prime factorization for that. So 108, that's 2 and 54. That's 2 and 27. That's 3 and 9. And that's 3 and 3. So this is 2 times 2 times 3 times 3 times 3. So we've got 2 squared times 3 to the... Whoa, that 3 got jacked up. 3 to the 3rd times, and then we have p to the 10th. And that's all in the radical. And then in the bottom, we've got the square root of 3 times p squared. Okay. In the numerator, I'm going to get some, let's make some room here. Okay. So we've got the square root of 2 squared times 3 squared times 3 to the 1st times p to the 10th. So now in the numerator there, we've had this 3 is going to remain in the radical, and then we have the square root of 3p squared down below. So this 3 is going to remain in our radical in the denominator. So numerator, we can take out the 2 squared, that's 2. We can take out the 3 squared, that's 3. P to the 10th will come out as p to the 5th, and then we have stuck in the radical that single 3. And then on the bottom, we'll have p, the square root of p squared is p, and then the square root of 3 is stuck in the radical. So a little bit of simplifying to do here, because we've got this square root of 3 and this square root of 3, so those can cancel. So we'll cancel those out right now. So this will cancel with that. And then p to the 5th over p to the 1st, that's going to be p to the 5 minus 1, so that'd be p to the 4th in the numerator. So we'll have 2 times 3 times p to the 4th. And that's just 6p to the 4th, which matches what we got in the beginning.